So we're going to continue with some problems dealing with circles. This is our second video segment on circles. We started on the circles handout last time in the previous video, and we got through the first few exercises. I think we're down to exercise number 5 now, so we're going to work on that together, and I have it written separately right here. Find the center and radius of a circle and sketch a graph if the equation is x minus 3 squared plus y plus 6 squared equals 16. So we want to get used to trying to recognize this general form of the equation of a circle. And notice here that it looks like we have that form. Pretty much, we got x minus 3 squared is like x minus h squared. Instead of y minus k, we have y plus 6 squared. So we got to make sure we think of that y plus 6 as y minus a negative 6 squared. That's telling us that the k value is actually negative. And notice the number on the right, too, the 16 there. You want to think of that as a value of r squared. So the radius is not 16, but the square of the radius is 16. So let's see what we can say here. We can say the center of the circle is going to be 3, negative 6. And the radius is going to be, well, if r squared is 16, r is a positive square root of 16, which is 4. So the radius is 4. And so we found the center and the radius. And in this problem, we also want to sketch a graph. So let's talk about how we would sketch a graph of a circle. I'm going to set up my coordinate axes. And I'm going to x, y. And let's try using just standard scale. So 1, 2, 3, 4, 5, right? Each square is worth just 1 unit if I use a scale like so. Okay, so I set up my coordinate axes. Now, what I want to do is I want to find the center is 3, negative 6. So to the right, 3, down 6. Okay, down here. And now the center is not actually, whoops, sorry, I went off my sheet. The center is not actually a point on the circle, right? We gotta draw the circle around that center. And it's not easy to draw a circle. What we're going to do is just plot a few important points and use those as a guide to draw the actual circle. So here's how we do it. We plotted the center, 3, negative 6. And since I know the radius is 4, I'm going to move away from that center in vertical and horizontal direction. So watch this. I'm going to count 1, 2, 3, 4 up. So that's like a distance of 1 radius up. I'm going to count 1, 2, 3, 4 to the right. I'm going to count 1, 2, 3, 4 to the left. And I'm going to count 1, 2, 3, 4 down. So I have, it almost looks like a diamond shape. But now those are 4 points on the circle. And then as best as I can, it doesn't have to be perfect, I'm going to try to draw a curvy circle, kind of connecting those points, but in a curvy circle kind of way, right? And so there that circle, that's my graph of x minus 3 squared plus y plus 6 squared equals 16. Has center 3, negative 6, and radius 4. I could label these points. I'm not going to label the coordinates. I guess maybe I could just mark out that what we've done is we've counted out those 4 units of the radius in each of the 4 directions, up and down, right and left, just to get 4 more points to guide the sketch of that graph. Okay, that's number 5. Let's go on to number 6. Find the center and radius of a circle and sketch a graph if the equation is x squared plus y squared equals 25. Now, we know the general form of the equation of a circle is this x minus h plus y minus k squared equals r squared thing. But in the special case where the center is 0, 0, the equation is much simpler, right? So it's okay to just observe right off the bat here, well, this is this special case where the center is the origin is 0, 0. And remember that constant on the right now, that's not r, that's r squared. So if r squared is 25, r has to be the square root of 25, or radical 25, which is 5, so the radius is 5. And so there's our center and radius. And let's go ahead and sketch a graph. It's actually much easier to work with this example than with the previous one, because it's a lot easier when the center of a circle is at the origin. And my center is at 0, 0. Here I can just count out 5 units along each of along the axes, because if I go straight up and down from the center, or right and left from the center, I just move along the axes here. So negative 5, negative 5, and try to draw a circle as best as you can. And there's the graph of the equation, x squared plus y squared equals 25. Again, notice that the radius is 5, even though we see that number 25 on the right-hand side of the equation. Okay, let's do a couple more here. Show that the given equation is the equation of a circle. Find the center and the radius. So what we're doing now is we have an equation here in A, x squared minus 6x plus y squared equals 27, that doesn't really look like the form x minus h squared plus y minus k squared equals r squared. So what we're going to have to do is we're going to have to work on this a little bit to put it in the standard form. And something we're going to do here is, it's called completing the square. And let's just look at these two x terms, x squared minus 6x. What I want to do is I'm going to add a number onto x squared minus 6x to complete the square. And you may have seen this process before. What I do is I take the coefficient of x and take the coefficient of x, I divide by 2, and then square what I get. So I'm going to take the coefficient of x, which is actually -6. I'm going to divide by 2 to get -3. And then I'm going to take that -3 and I'm actually going to square it to get +9. +9 is what I'm going to add 9 to both sides of that equation. So I want to add a 9 right here next to the 6x. I'm going to add it before I write the plus y squared, which is just there from before. The 27 on the right, I have to also add a 9 to. So whatever I do to one side of the equation here, I have to do to the other side. I'm adding 9 to both sides. Now the reason I've done that is I can now factor these three terms to the left, the x squared minus 6x plus 9. That, thought of as a trinomial, that will factor into x minus, not too hard to see, 3 and 3. The point is I wanted to get both factors being the same, and they are. So I actually can write that as x minus 3 in parentheses squared plus y squared equals 27 plus 9 is 36. So I now have the equation in a form. It's actually in the standard form where I can read off what the coordinates of the center and what the radius is. The center is going to have x coordinate 3 because I have that x minus h squared. Now notice I have y squared by itself. When you have y squared by itself, it's just like k is equal to 0. It's kind of like similar to a circle centered at the origin, but here we don't have both center coordinates 0, we just have the y coordinate 0. So the center's at 3, 0, and the radius is going to be the square root of 36. Just notice this is r squared, so our radius r is the square root of 36, which is 6 units. So we found the center and radius of that circle. Just notice that this form of the equation is what we'd call the standard form. So we put the equation in standard form so that we could see what the center and the radius were. So let's do another one of these. Okay, we're going to do another one in part B. And it's a little bit more complicated because we have extra terms for both x and y. I have an x squared and a 2x term. I have a y squared and a negative 8y term. So I'm going to rearrange with x squared plus 2x, and I'm going to leave a little space, plus y squared. Then I'll write the minus 8y. I'm going to leave a little space. And the 13 I'm actually going to take to the other side. I'll actually subtract 13 from both sides. So I'll have negative 13 on the right. Now we're going to go back to that process of taking the coefficient of a variable, dividing by 2, and then squaring, kind of like what we did before. So I'm going to take the coefficient of x here is 2. I have to divide it by 2. 2 divided by 2 is 1. Then I have to square it. I got to take the 1 and square it. Well, that's still just going to be 1. I'm going to add 1 to both sides. The y coefficient is negative 8. Take negative 8 divided by 2 is negative 4. Then take that negative 4 and square it is 16. I'm going to add 16. Okay? So I left space up here to write in some of this. The x squared plus 2x, I'm just going to add 1. The y squared minus 8y, I'm going to add 16. But now, whatever I do to one side, I have to do the other, so I got to add a 1, and I have to add 16 to the right-hand side to keep an equivalent equation. Now let's come down here and see what I got. The x squared plus 2x plus 1, I can factor into x plus 1, x plus 1. The y squared minus 8y plus 16 will factor into y minus 4, y minus 4. The right-hand side, when I add up all those terms, is going to be negative 13 plus 17, I think is 4. Now, you don't have to write these two factors separately here and here. Both pairs separately. You can just say x plus 1 in parentheses squared. That's the way we want things. Plus y minus 4 in parentheses squared equals 4. Here's our standard form of the equation. And from the standard form, you should be able to read off what the center and the radius are. The center is, now that x plus 1, to see the coordinate of the center, you got to think of that as x minus a negative 1 squared, right? So the center actually has x coordinate negative 1, y coordinate is 4, and the radius is going to be, so that 4 on the end, now remember that's r squared. So r squared is 4. The radius r is going to be the square root of 4, or 2. So there's the center in the radius of the circle in part B. And so that's a good example of converting an equation to standard form so that we can read off the important information about the center and the radius. So we'll stop there with this segment and do some more problems in part 3 coming up.